Okay, so this one's going to be a little bit slower. In this one, we're just talking about what speed distributions are going to look like when we put them on a graph. We're going to look at the percentage of particles at any given speed given the average temperature. So, since velocity at a given temperature is just an average, some particles will be faster and slower. So what's this going to look like when we put it on a chart? Well, here we have our percentage of particles, and here we have their speed. Remember, speed is just reflecting how much energy they have. We'll put it in meters per second. Let's say we have a VRMS speed of 600 for an object. So let's put 400 here, 800, 1200. We've got an object with a VRMS speed of 600. That means most of our particles are going to be right there. So we'll have some particles with almost no energy, and then we'll distribute out like this. So our VRMS right here, VRMS equals 600 meters per second. Now what's going to happen, you see higher percentage near the average, but we do have some that are all the way down here, some all the way over there. If we look at something with, I don't know, let's say 1,000 for its average VRMS, what's going to happen is the particles will more evenly distribute themselves. So you see your peak is not as high. This would be VRMS 1,000. Your peak is not going to be as high because there's a wider range of velocities that your particles can have. At this higher temperature, with a higher average speed, there's more possible distributions, meaning it's going to be flattened out. This is the reason why Earth can't hold on to hydrogen, because what happens is as particles randomly distribute, let's say anything beyond this point would get lost into space. As particles keep heating up, there are going to be some that just continue to get a little bounce and get a little more energy. They're going to leave, which is why we can only hang on to certain gases. But this is all we really got for VRMS speed and the Boltzmann distribution of particles.